There we go. We are on Unit 3, Lesson 11. First off, I just want to get this out of the way. Since I'm not here today, don't worry about your stamps. For this tracker, this pink tracker, I'll just go ahead and give you all your stamps on Monday. Okay? So we are on page 44. And for the starter activity, it's a which one doesn't belong. So we're going to do this one a little different. What I want you to do is pause the video, and I want you to try to come up with a reason why each graph doesn't belong. Okay? I know normally we just pick one here. I want you to take a minute, pause the video right now, and see if you can come up with a reason why each graph doesn't belong. Go. All right, so hopefully you pause the video and you have a reason for each one. What I noticed about each ones, and these may be different from the reasons that you came up with, but what I came up with for A, I'll start with A, we have two parallel lines with a negative slope, and it's the only one that has a negative slope. So I'm going to put that down there for A, parallel, parallel with negative slope. Parallel with negative slope, okay? Because it's the only one that does that, so that's a reason why A might not belong. That's the nice thing about which one doesn't belong is you're never wrong. There's always a reason for each one, no matter which one you pick. For B, I'm looking at that, and it looks like they're not parallel. Well, now, one thing I talked about with the classes the other day is that we can't just go based off of looks. I mean, these ones are obviously not parallel, but even for A and C and D, to prove that two lines are parallel, remember you just check to see if they have the same slope. Okay, so these ones, if I check them, they would not have the same slope. We can see that. For C, I'm gonna say it's not belonging because it's the only graph with a zero slope. So remember we learned that earlier this week in one of our previous lessons that a horizontal line has a slope of 0. And then for D, so there's a couple different reasons. One thing I noticed is that it's the only graph that doesn't have a line with a y-intercept of 10. If you notice, all the other graphs, so I'll scroll back down a little bit, A has a line that has a y-intercept at 10 right here. B has a line that has a y-intercept at 10 right here. C has a line that has a y-intercept at 10 right here. But D, it doesn't. So I'm going to say that's my reason. Now, of course, you could have come up with other reasons for all of these, but make sure you have a reason written down. All right, I think now would probably be a good time to remind you when I'm absent and we have to do our notes like this. I know it's not the same as me being there, but you've got to get everything copied down for the notes, okay? You will not get your stamp for having completed this lesson unless I see all of those notes written down. So just make sure you're copying down all of our notes. Our first activity past this starter is, looks like we've got a graphing activity here. It says all the same. So I'm on page 45 now. It says plot at least 10 points whose y-coordinate is -4. Okay, I'm going to go ahead and change that for you to say plot, I got to zoom in, plot and label. All right, I want you to actually write out the ordered pairs that go along with these points that you plot. So all of them have to have a y-coordinate of -4. So on the y-axis, I see -4. I'm going to just go ahead and start plotting points. So here's 1, here's 2, here's 3, 4, 5. I'll go 6, 7, 8, 9, and 10. So there's my 10 points. But then I asked that you also write out those ordered pairs, right? So I'm going to do that. My ordered pairs are, my first one is -6, -4, and then -5, -4, and then -3, -4. Then I've got -2, -4, -1, -4, 1, -4. Again, I'm just writing down these ordered pairs. Then I've got 3, 4, 5, and 6. Okay, so 3, -4, 4, -4, 5, -4, and 6, -4. Okay, so I've got all my ordered pairs right now. And then it says, what do you notice about them? Well, from the graph, one thing I notice is that they form this straight line. Right? So they all go in a horizontal line. Okay. One thing I notice about the ordered pairs is that, no matter what the y value or what the x value is, I'm highlighting this, my y value was a -4, right? Which makes sense. I mean, it said that the y coordinate was going to have to be -4, but it's really obvious that, these -4 y values form this particular horizontal line when I put the two together, okay? So what do I notice about them? They form a horizontal line. They form a horizontal line. Whose y values are all the same, right? They're all at that -4 all across that line. So which equation, the next question says, which equation makes the most sense to represent all of the points with a y coordinate of -4? Well, because no matter what the x value is, I get a y value of -4. I mean, look at all those ordered pairs. I highlighted all those -4s, right? Because of that, it makes more sense for our equation to be y equals -4. It's not based on x at all. X doesn't matter, right? All of these y values are the same. So that's why that equation makes the most sense. It says, explain how you know it didn't matter. The x value. Y always equals -4, right? So that's why that equation makes sense to me. And that actually is going to be the equation for a horizontal line, okay? So for here, number 3, I'm going to do this in a different color. Let me change that real quick. It says plot at least 10 points whose x-coordinate is 3. So I'm going to change that for you again. I want you to plot and label. I want us to see what these ordered pairs look like, okay? So 10 points whose x-coordinate is 3. So here's 3. I'll just go ahead and start there. I'll put a point there where x is 3. And then this point also has an x-coordinate of 3, and this one, and this one, and this one. And then I'll go here. How many am I up to? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. All right. So to label all of those, I'm just going to start on the top and work my way down. It goes all the way to 3, 6. And then what we got? 3, 4, 3, 3, and 3, 2. 3, 4, 3, 3, 3, 2. And then the point that I did on the x-axis, which is just 3, 0, I've got 3, negative 1, 3, negative 3, and 3, negative 4, 3, negative 5, and 3, negative 6. Okay, 3, negative 4, 3, negative 5, and 3, negative 6. All right, so all of these ordered pairs written out, I notice again, boom, now all of my x values are the same. Another thing I notice is all of these points form this vertical line this time, right? When all of my x values are the same, I've got this vertical line now that gets formed. The magic of the iPad didn't help me out there. That's not very straight. But you guys have your rulers, so make sure you make a nice straight line. So what do I notice? Again, it forms a vertical line this time, right? And all of those x values just happen to be the same. Okay, if you look at that line, it's a nice vertical line there at x, the x value of 3, right? So which equation makes the most sense? Well, this time, it's the opposite. Look, our y value changed. Look at all of those ordered pairs, right? The y value changed, but did the x? No. The x always equals 3. That's why that equation fits for that vertical line, okay? These special graphs, you'll notice, don't have both variables, right? Most of our equations have both variables. They had a y and an x, but these are special. A horizontal line doesn't have an x in it, okay? It just crosses the y-axis. That's how I like to think of it, okay? This vertical line doesn't have a y in it. It just says x equals 3. And that's because it doesn't cross the y-axis. That's how I like to remember it. So a vertical line goes up and down. It's only going to cross the x-axis. So the equation is x equals some number. For a horizontal line, it goes side to side. It's not going to cross the x-axis. It's only going to cross the y-axis. So that's why the equation is y equals some number. In fact, I want us to write that off to the side, because I really think it's important that you remember that. So off to the side, I want you to put this for a horizontal line. All right, I want you to underline it also. Okay, for a horizontal line, it's always going to be y equals, and then I'll just put some number. Right? There's no x. It's just y equals some number. That number is where the horizontal line crosses the y-axis. For a vertical line, and I'm going to underline this too, my equation is always going to be x equals some number. And that is because it only crosses the x-axis, because it's going straight up and down. It won't cross the y-axis. So it's just x equals some number. That number is wherever it crosses the x-axis. Okay. Having said that, now let's move on to question number 5. It says graph the equation x equals -2. So because it's x equals some number, right? That's this one right here. The vertical line, x equals some number. I'm going to graph that vertical line at x equals -2. And I'll do this in a different color so it doesn't blend in with all of our other ones. So x equals -2 is just, oh, magically iPad let me down. I'm going to try that again. It's just this vertical line right here. Okay, right there on the x value of -2. For number 6, it's the opposite. Graph the equation y equals 5 because it's y equals some number. Boom. It's a horizontal line at the y value of 5. Man, I'm missing the line somehow. Hopefully you guys do better than me. All right, beside each of those, I just want you to put those numbers just so we know where they came from, right? This came from problem number 6, this horizontal line, and then this vertical line came from problem number 5, or question number 5, right? All right, on the next page, we've got this little activity with rectangles, and it's talking about a rectangle with a perimeter of 50. So I've got all these different possible rectangles. They can all have a perimeter of 50, right? I can just change their dimensions and I make that work, right? So visualize, I'll draw one off to the side here. Visualize a rectangle. My iPad is letting me down. Come on, iPad. There we go. We got a rectangle, okay? So with the length and the width, it should, when I add up all of the sides, remember that's what perimeter is, when I add up all of those sides, it should add up to 50. Well, I'm just going to start with some random numbers, okay? What if my length is, let's use a different color. What if my length is 1? Right? So that means the lengths are 1. So that's 1 on one side, 1 on the other. That's 2. Well, I'm supposed to add up to 50. So 50 take away 2. That leaves me with 48 for the other two sides. And because a rectangle has those two sides being equal, right, I have to divide that by 2. 48 divided by 2. That gives me a width of 24. All right? So 24 plus 24 plus 1 plus 1 does equal 50. Well, what if the length is 2? You see what I'm doing here? I'm just creating a pattern, trying to find a pattern. So if I increase the length, so now I've got a length of 2, so that's 2 on one side, 2 on the other. 2 plus 2 is 4. Take that away from 50. 50 minus 4 is 46. 46 divided by 2 is 23, right? What if it's 4? If it's 4, 4 plus 4 is 8. 50 minus 8, 42. 42 divided by 2 is 21. Okay, and just keep going. I'm going to write in all the values that I came up with. If you think of some different ones, you can, right? But they have to add up to 50. All of the sides together have to add up to 50. So I've got 1, 2, and 4. Let's do 5 and 20 next. Let's do 7 and 18 next. Let's do 12 and 13 next, and then 14 and 11. I got 3 spots left. Let's do 19 and 6. There's a lot of different ones, so I'm just picking some. Let's do 22 and 3, and last but not least, let's end with 24 and 1. All right. So if I had a rectangle with these dimensions, it would have a perimeter of 50. Now it says here, the graph shows one rectangle whose perimeter is 50 units. So you can see here, actually maybe you can't. On your books, I don't think this showed up real well. Go ahead and darken this in. So there's this line right here and right here. Okay. What they did was draw in a rectangle. So they have 15 length and a 10 width for that rectangle. Check that real quick. 15 plus 15 and then 10 plus 10 and add those together. 15 plus 15 is 30, 10 plus 10 is 20, 30 plus 20. That does equal 50. So they have one example here of a rectangle. They just drew the rectangle on the grid, and it says the lower left vertex is at the origin. So you can see that right there. So this rectangle, boom, if I were to finish tracing it in, would have its one corner down here in the origin, right? But we don't actually have to put that there. I'm going to get rid of that. Okay. So you're going to draw in our values from the table, okay? When we do that, you're going to notice a pattern, right? So it says make sure each rectangle has its lower left vertex at the origin, and then its two sides will be on the axes. In other words, don't draw it tilted. Okay, just draw it like they have drawn their first one. So our first one was a length of 1 and a width of 24. Length of 1 and a width of 24 looks like that, right? a very thin rectangle, but it's very wide. So the next one that we had was 223. Is that right? Yeah, I'll scroll up so I can see both the table and the graph at the same time. So 2 and 23. So 2 and let's see, there's 20, 21, 22, 23. There we go. There's our next one. So a little bit thicker rectangle, right? But it made it not as wide. Our next one, let's keep going. 421. 421. There we go. 520. You may already start to be noticing the pattern. That's good. My side got a little messed up there. 520 is up there. 718. Oh. Yeah, let's straighten that bad boy out. 18. So I did that right. Good. Yeah, that's what I should have been doing the whole time, using the magic of the iPad. There we go. Nice straight line. 12, 13 is our next one. So there's 10, 11. Here's 12. Ooh, too long. So what we got? Here's 10, 11, 12, 13. Got that one. 14, 11. That one's off a little bit. I don't like that. There's 14, 11. 19, 6. Magically, iPad failed me there. 22, 3. 20, so there's 21, there's 22. 1, 2, 3. And our last one was 24 long and only 1 wide. All right. You should notice something, right? Yesterday, sorry, the other classes were saying, hey, it looks like steps. Okay, so it kind of does, right? Not uniform steps for sure, but it does look like steps kind of. And the point of that is it's forming a line. If you notice, I could draw a line now. I'll do this in a different color that connects those corners of all of those rectangles, right? And with the magic of the iPad, you guys use the magic of your rulers. We've got this line that hits that top right corner of every single rectangle. And you can see there's some rectangles that we missed, right? So there's some values in there that you could have come up with. We've got this nice line. Now, what do you notice about this line? Hopefully, you notice that it has a negative slope. It's going down from left to right. So because it's going down from left to right, I know it's a negative slope. Look at all of these slope triangles that we have drawn on here that got formed from the rectangles, right? I've got all these different rectangles or slope triangles to pick from. I'm going to zoom in. I'm going to do this one right here, this one that got formed. If I notice this, it's down 1, 2, 3, 4, 5. So I'm going to put that as -5, not just 5, just to remind myself that this slope is negative. Okay, we talked about how you guys have a tendency to forget to add the negative after you figure out what the slope is. But then I'm going over 1, 2, 3, 4, 5. I'm going over 5. All right, so my slope would be -5 over 5. Or just -1, right? Because any number divided by itself is 1, and then that negative makes it a -1. So I've got the slope. Now, why am I even thinking about the slope right now? Because I noticed it says draw in this line and write an equation for it. Remember, our equation should be y equals mx plus b, where m stands for the slope. Well, that's good. I just found the slope. B stands for the y-intercept. So the y-intercept is where it crosses the y-axis. We think of that as the starting amount, right? But it's where it crosses the y-axis, and I can see up here where it crosses the y-axis. It crosses right there at 25. So now I know both things that I need to write my equation. I can write my equation. My equation would be, for this line, y equals negative 1x plus 25. Or you don't even have to have the 1 there. You could just have negative x plus 25, right? Because we know when x doesn't have a number in front of it, there's really a 1 there. All right, what is the slope of this line? How does the slope describe how the width changes as the length changes, or vice versa? Well, we already said the slope is negative 1. Okay, I'm going to make it a fraction, and the reason I want to make it a fraction is because that makes it easier to describe what's happening, right? We know slope is vertical distance over horizontal distance. We know that. Well, what's measuring the vertical on this graph? It's length, right? So that negative 1 length for the horizontal on the bottom, that's a positive 1. That's the width, right? So what is that saying? It makes it easier when I write it as a fraction to see this. It's saying the length goes down 1 when the width is a positive 1. So the length decreases by 1 every time the width increases by 1. Okay, do you see how I got that from that slope? When I write it as a fraction, it makes it a little bit easier to see what it is actually describing. So I'm going to put that. The length decreases by 1 each time the width increases by 1. All right. So we got the lesson done. I want to put a big box around this, and I want you to do that on your notes too. That's important. Okay, we're using that form of our equations for these linear relationships. So we need to remember that M stands for slope, B stands for y-intercept. You always start with the y-intercept. That's your starting amount. That's your beginning amount. It kind of made sense. We said that they use the letter B because we think of that as the beginning amount. That's where the graph begins. And then the slope. The slope is how you get to the next point, right? So you're going to start on your homework. Your homework's on page 47. You can watch the answer key video to help you out with that, or you can try it on your own, and I can grade it when I get back. Nah, never mind. Watch it. Watch it anyways. It'll help.